Hello, this is Mike at GameFromScratch, and welcome back to the ongoing Closer Look at Game Engine series. This series is intended to help you decide if a game engine is a good fit for you. It's a combination between a review, an overview, and a getting started tutorial to give you, in an hour or less, a good idea if a game engine is right for you. As always, there is a text-based version that goes along. I'll link it down in the comments below. Now, today what we are looking at is the Atomic Game Engine. The Atomic Game Engine is a commercial engine, so it costs money. Right now it's in early access versions, so it's very much a work in progress, and be aware of that. It's also based off of the Urho. I'm not actually sure how to say it. I covered it earlier, but the UHRO 3D open source game engine, which is a number of years old, or 6 or 7 years old now at this point, and Atomic is built on top of that. Now, a lot of the times you would think, oh crap, you're a commercialized version of an open source engine. That's not cool. Well, in this case, it's not such a bad thing. First off, it actually does bring something new to the table. One of the big challenges with, I'm going to say Urho, was the tooling was, shall we say, a little bit ugly. And on top of that, the scripting language of choice was the somewhat obscure AngelScript. Now, the Atomic Game Engine is going to add a series of very polished tools on top. And obviously there's going to be some engine changes. It's a fork, and so they based it upon Urho 3D, but they've changed the code and cleaned it up. And also they've added a number of language bindings. So that's one of the big things that could be of interest to you here. The languages that you can work with for Atomic. Well, first off, it's written in C++. And technically you can do all of your work in C++. However, especially being the work in progress part, there's not a lot of documentations, or there's actually no documentation on working from a C++ point of view, except for, of course, all of the underlying Urho documentation with some modification is still applicable to you. But on top of that, the primary language that Atomic works with is JavaScript. There's complete language bindings in JavaScript, and the documentation is in JavaScript. But in addition to that, there's also .NET bindings and TypeScript bindings, officially from the Atomic team. However, on the other hand, there's also been a community-based set of bindings for the Haxe programming language. So if .NET, JavaScript, or Haxe are your thing, definitely give Atomic a check out. Now, if it's C++ is your thing, it's also a good option, but you may, in that case, want to stick with the underlying Urho 3D. It depends on, the value proposition is a little bit less in that case, but it's still quite solid. Now, another thing to keep in mind here is it's actually a source licensed engine. So you can get access to all of the source code. When you buy this, you can actually pull it down from GitHub, build it yourself, and all you have to do is run it through a license and you're good to go. So all of the source code is available. So that's one of those big appeals over something like the Unity engine, for example, is you do have the source code. You can jump in and modify things to your heart's content, or to debug those tricky, hard-to-find processes. So you're never at the whim or the will of the provider. All of the source code is there for you. So from a technical point of view, it makes sense for this engine to exist on top of Urho. Now, the other thing is, and I guess this one's kind of big, is they're just not being dicks about it, which is really kind of cool. So yes, it is a commercial product built on top of an open source product, but if you are a contributor to any of the contributing open source projects, be it obviously Urho or Box2D, TypeScript, Tiled, or the various other things that it works with, if you contributed to any of those projects, you can get a license completely free. Just fill in the form and they'll hook you up. So yes, it's built on top of open source technology, but it's built on top of it, so the source code is still available to you. The player that they've used is MIT licensed. The code is available. It's not being retroported back, unfortunately, but it is available. So as far as playing nice with an open source product, they've done a solid job. So they've not been dicks, basically, which is nice to see. I get some projects in the past that basically just forked something, commercialized, and started charging money. And yeah, that's not cool. So their approach is pretty nice. I like it there. Next up, we're going to talk about the pricing structure. And it's pretty solid. The nice thing right now is, as I mentioned earlier, it's currently in early access pricing. So you can get in, there's a completely free version, I guess I should mention that. There's a completely free version with the limitation being you can choose between the 3D support, Android support, or iOS support. So that's obviously a limitation there. Or for $95 you can get all of that. However, that $95 is tied to your income. Plus that community version has a couple more limitations. There's a splash screen on it, and an annual revenue limitation of $100,000. So if you're working on just Windows, for example, or just desktop, Mac, Windows, etc., the community version will work you just fine as long as you're okay with having a splash screen up there and you make less than 100 grand a year. Now the indie version, which is currently 95 bucks, is limited to $500,000 annual revenue, and that's it. And then there is a full-blown studio version for $495 early access pricing, and you're good for up to $5 million annual revenue. And any more than that, you got to negotiate a deal directly with them. Now, reasonable pricing across the board. I'm cool with all that. Now keep in mind this is early access pricing. When it ships, the indie version will be $295 and the studio version is $1,500. Now the cool thing about all this is if you get the early version, it includes a lifetime of free upgrades. So this is a pay once and never again type licensing system. Now, of course, they are competing with a lot of free options, so let's make sure that they bring enough to the table to justify any kind of purchase. So without further ado, I suppose we could jump right in right now and take a look at the engine. Now, I suppose I should show you, let me bring a browser up here, where to get the engine. And that is at Atomic Game Engine. Oops. Well, inadvertently, that will get me there. AtomicGameEngine.com is where the engine can be downloaded. Now, one of those things to keep in mind is the binaries available are made available as they are made available, basically. So if you want the current, most up-to-date version, you're going to want to get a subscription so you can download and build it. Otherwise, you basically are waiting on release versions. But you can just go ahead and download it straight away. Just come on in here, down it for either Windows or Mac. Now, in terms of, let's talk platform for a second, the Atomic Game Engine is capable of targeting, obviously, both of those platforms, as well as web, which is included in the free version, coincidentally, Android and iOS. So most of the major hitters are there. There's no Linux support as of yet, both from the editor and as a platform. I'm not sure if that's in the cards, to be honest. You'd have to ask them specifically on that one. So let's just fire up the Atomic Editor. And this is the heart blood of it. This is basically like this is the equivalent of the Unity editor, for example. And we're just going to do a quick tour of what the editor has to offer here. And you can see there's a number of samples available right off the hop, and you can also get them from the GitHub code. We'll see that later on in this video. But your editor is quite clean, makes a lot of sense. I'm just going to go ahead and I'm going to open up one of these sample projects, and that's what we're going to use for this entire demonstration. Well, before I do that, I suppose I'll show you the process of creating a simple project. It's very simple. You just kind of come in here, say new project, and you pick, are you making a 2D or a 3D game? Now, keep in mind, you need to have the 3D module to go ahead and make a 3D game. I'm running a full indie license, so your experience might be a little different with the downloaded version based off of which options you chose. So I'm just going to go ahead. I'll pick 2D here. You pick where you want it to go, and I'll call this YouTube demo. And right now, pick your target language. You can pick between JavaScript and TypeScript as it stands. Now, don't worry, you can actually work on using the other languages. You're just not using them directly in the editor itself. And just go ahead and click Create, and you're done. And this is the basic heart of your editor. Up here, you see the resources of your game. So you can create new folders, but basically scenes, scripts, sprites, components, etc. all come up here. And then within each folder, you can see the available options right here. Now, as you saw, when I selected main.js, the integrated text editor is brought up and displayed. Now, this text editor is in the process of being changed. It used to have code completion and a few other features that are unfortunately currently removed. And another big negative right now is there is no direct debugging support right in the editor, which is a little unfortunate. But they're in the process of porting this entire thing to Chromium, and with that, hopefully we will get code completions back and hopefully integrated debugging, etc. Now, the thing to be aware of, again, is you are in early access. So some things are going to be broken, some things are going to change, etc. as time goes on. Now, this isn't as negative as it sounds, though, because it's built on top of a very mature game engine. So the fundamentals, the things you need to make your game, things like your scene graph, your rendering, occlusion culling, input handling, etc. All of those code bits are very, very mature. So don't worry, it's more the interface on top of them or the game organization stuff on top of them where the changes are going to happen. So back to our preview here. So you've got your list of resources here, your details for each particular one. So if I come in here to sprites, we can see I have a single sprite in there named star.png. And then down here we have the hierarchy. So I'm going to go into scenes, select our current scene, and then you can see the scene hierarchy. Now, in another platform, this would probably be known as the scene graph. Essentially, this is all of the nodes that make up your scene. Now, for all intents and purposes, the Atomic Editor and the Atomic Game Engine is an entity component system. It's just they don't use the word entity. Instead, they use the word node. But your node is essentially a package of components. So we see here we've got a node. I can select it here, and it syncs up over here. But this node is simply a component container. So node has positional information, as you can see over here, but it's also got a couple of components attached to it. One of which is a script. So it's got the component star.js script, and the other thing is a sprite. So that links back. So this is our node is composed of this sprite and this script. So essentially that is how you put these things together. It's over here again, your resources, your actual selection within said resource, your scene graph, and then over here you have your components. And even when it comes down to your scene graph is quite simple in composition because you have two types. You have the node, which then will contain various different kinds of components, and then oddly enough you have this single 3D light component, which I don't know why that isn't simply a node, but that's it. So those are your choices. Then the majority of your logic is going to come over here. So let's go ahead and we'll just go ahead and create a new node in our game world. So our scene, switch back to our scene editor, and let's go ahead and go create new node. So we have another node in our scene. I shall click here. All right, which one do I have? All right, I'll grab this guy, and we'll change this to my node. And we'll just use the manipulator here and move it up a bit. Now, obviously, it's just the manipulator. There is no actual anything attached to this node. It's got no components. It's just a node, which is just positional or spatial information, and that's it. So let's go ahead and add a component on top of it. And here are all the component selections. Here's your audio, all your 2D stuff. Neat thing is like there's some pretty complex supporting here. Like we can bring in a TMX tile map from the tile level editor, for example. Geometric nodes, logic nodes. So basically this is how you attach your C# or JavaScript scripts to, and that's where you provide your programmatic logic to each particular node. Navigation, networking, physics, scene, subsystems, and editor. So we'll go back, and really we're just creating this again. So 2D, it's a static sprite. We go in, we pick our sprite, like so, drag that over, and well done. That's pretty much all it takes to add a component. Now let's go ahead and add another component to here. So is it here or is it, yeah. So we're gonna add a 2D rigid body to this guy. So we're adding physics to our node right here. Body type is dynamic, and let's just do a preview, and boom, it drops. So that's how easy it is to add new components, new functionality. Physics was that simple to add in. So it's a very nice, polished way of working. Now 3D is very similar. It's actually the exact same interface. It's just your root scene graph is obviously 3D as opposed to 2D. And we'll see that probably in a bit when I go to the pre-made sample. Also tucked nicely in behind this entire interface is the asset importing pipeline. So when you bring content in here, such as a sprite, it will automatically load the appropriate loader. This is obviously more important when you start dealing with 3D. So you bring in an FBX file, it'll automatically trigger off the appropriate importer. So for example here, let's bring this sprite in. We'll drop it into the sprites folder, like so. And now when I click here, you'll now see we have this additional sprite available. So I can grab this guy and go into his sprite, and it's available there. So dragging, to add new contents or assets into your new resources to your project is a simple matter of literally just dragging them, drop in here. You can also create new folders, new scripts. You can have your own folder structure here as you wish, but literally just drag and drop in, and you're good to go. Now let's take a quick look at the programming going on behind the scenes. I'll bring up a more advanced example in a second, but the logic of the simplest one here is probably the nicest way to start. So let's just go on in here and let's look at our scripts folder. And this is where your game starts. And this is the very, very plainest bare minimum main entry point you've got. And really all it's doing is calling into the global atomic namespace and player loading, and then loading our scene file. So our scene file is obviously named scene.scene, and that's it. That will trigger off everything, and everything is good to go. Now, how does this actually trigger and cause to do anything? So if I go ahead and here up and play, you'll see like this guy, for example, is spinning. So there's some logic attached to him. Well, that was, if we go on back to it, so we'll grab that node in this here, you'll see that this JavaScript component is attached to it, and it is the star.js script. So we'll bring up that guy. So that's under components, star.js, and here's the source code for it. Sadly, I can't zoom that in, so hopefully it's legible to you in this video. But all it's doing is it's using the common JS module system for JavaScript, and you're just exporting out this function, and the key thing inside of it is this update call. So that is your traditional game loop update function is going to, a callback function is going to be called for this component. And so every frame it's going to be called given the time step, the amount of time that's happened since, and each component has access to the node that it's attached to. So in this case, we're just saying to our own node, let's rotate it two-dimensionally by 75 times speed times the time step. Now the neat thing is this inspector field, so you see speed at 1. So let's go on back to our scene graph again. We will see up here for our JS component that that's property, that this value right here is being exported out. So we could change the speed of our star right there. And so you can easily give your designers access to your underlying code quite simply, quite powerfully. So that's kind of cool. So that is a very, very simple case. Every program has an entry point, and again, in this case, it's a main.js, and all it's doing is firing off the scene. And then in this case, each of our components is just firing off an update that's automatically called for that component by the game engine itself and doing whatever logic accordingly. So that's a very, very, very simple example. Now let's look at a slightly more advanced example. So I'm just going to come in here and close this project, and we're just going to go ahead and create an instance of the platformer. And I don't know what it's called, so we'll go with actually YouTube seems pretty safe. Platformer. Again, I'll just go ahead with JavaScript and create that guy. So now you'll see our scene, so our resources are quite a bit more advanced, but we'll grab our scene, and you'll see the instances in our scene, it's not really that different. I got a cord wrapped around my leg, just a second. All right, so let me just pan that down. Oops. All right, use the wrong orbit. Let me just, oops. I'll just zoom out. But there you can see your level. Very, very done. I did the wrong panning. I don't remember the exact command for panning or the proper zoom. So let me just go there and 1 second. All right, sorry, I undid my mess. First off, you can do F to frame the current selection, and then with the right mouse button down, you use the, all right, why are you not focused? The Q in the E key to go up and down, and WASD keys for in and out, left and right. Be honest, it's a little counterintuitive, but anyways, that's your scene. So we look over here, we can see here, our camera is focused on this particular region itself, and you can see we've actually got our level map here. Now, as I mentioned earlier, we can bring in tiled tile maps. So this is actually a, so come in here, we see, where did you go? This is bringing in from a tiled map level. You can actually jump into it and interact. Should be able to set it here though. Oh. Is it being loaded with script? Anyways, it doesn't really matter. As you can see, you can jump into the actual contents of the tiled editor, which is pretty cool. If you've got any interest in tiled itself, I've done a good multi-part, 4 or 5 part tutorial series on using tiled. So you can easily do 2D based level editing externally and bring it in here, but you still have nice integration once you're actually in. Here's some audio hookup. You've got, so here's this like a sound source, for example. So this OGG file is being played automatically by script. The sun, which is another neat feature, is you actually have dynamic lighting available in the 2D mapping. So when you actually go ahead and play this, there is lighting available. Let me just go ahead and actually show that. So we will play during. Sorry. I'll shut that down. Sorry about the volume. But as you can see, it's a pretty complete, full-featured game, full tracking camera setup. And now let's look again at its programming interface. It's the same basic premise. It's just in this case, so we still got our main coming in. And so our main is doing a little bit more, but not really a ton. You know that pick the daytime, pick the nighttime UI that was just popped in front of us? Well, that's what this is doing. Basically, you're just creating that scripted code. So you can see here, creating the label, creating each button, and the code that actually runs when you do the button, and then depending on which one you pick. The next thing this is doing, this whole entire section of code here for the most part, is just setting up, let me see if I'm actually consistent on this one. Where's the if? Yeah. So this if block right here is just setting up an on-screen controller if your platform is either Android or iOS. So realistically, there's not a lot more actually happening here. It's still quite simple loading. And again, this was your UI that's fired off, and then an on-screen controller creation. That's your main. Then the rest is going to be, again, in your components. So here you've got the various pieces that go together. So here is the player's, the logic or code controlling your main player. And again, it's JavaScript based, but it could be TypeScript, C#, Haxe, etc. And it's all just callbacks. So you see here it's implementing the start and update, and then just animation logic and input handling. So you do break your components up into and handle the various inputs, various events, such as, again, like you just saw, start and update. And 9 times out of 10, those are the only two you're actually going to need. But that is how you break your game logic out. Now, a neat concept here, and I can illustrate it nicely in our levels script. Let me bring that guy up. So level.js. So this is attached to the, I think it's attached here. Yeah. So it's when our level map is actually loaded. This is the script that's attached to it. And here you can see we've triggered into the start, and I think that's the only one it handles. And so this script is going to fire off when the level map inside of our scene is loaded. And this is essentially the heartbeat of this particular example. And you'll see one thing that it does down here, this is very cool, is, for example, here. You see var node scene.self.create child prefab, magic word there, prefab coin. So basically it's gone through and grabbed all of the entities from the level. So basically where we placed a coin object inside of tiled map editor, it's going through and finding every reference to that and instead instancing a prefab named coin. And prefabs are super simple to create. Basically all we do, so here you see this folder called prefab. So we've got this bat prefab, coin prefab, hero prefab, etc. Down here. Now to make one, it's just a matter of, so I'm gonna muck with this example a little bit, but inside, so let's go back to our scene. I just go create new node. So our prefab is, say, create sprite, like so. I'll go ahead and grab, I'll use one of the built-ins. Oh, not that one. So we'll grab the hero sprite. So you see it's a sprite sheet. I'm not going to be using sprite animations in this thing, actually. You know what, that's a bad example. Then I'll grab just something a little bit simpler. We'll use our old-fashioned star. So you see our star is now attached to this particular node. And let's say it also had a, what else are we going to attach to it? Audio, sound source. And audio attached to it. Okay, so those two things together. Now, in order to turn this into a prefab, let me give this guy a name. Coin with audio, like so. To prefab this guy, just go up. I thought, come on. Okay, one. All right, a bit of a demonstrator's curse, but basically all you should need to do to create a prefab is to take the node here from the hierarchy and drag it into the prefabs folder. But for some reason this isn't working for me, so instead of dwelling on this for a long time, I'm just going to go ahead and move on from here. But you kind of can pretty much see what's going on here. You've got your scripts kind of trigger your the heart of your game, and then you break your logic up into components, which are easily scripted using JavaScript in this example, or any of the other supported languages as you wish. You go ahead, preview your game right up here, And then when you are finally done, building your game is pretty much trivial. So you come up here and go to build. Or what we're going to do in this case is build settings. So I can show you some of the options. But I come in here, build, and you pick the platform you want to build for. So build for HTML, iOS, Android. You're seeing each one I pick is giving you different sets of options. So if you build with Android, you got to give it the JDK path so it can build with. And then you pick the Android level you wish to use, which I don't have this defined, so I don't have any options there. Mac, otherwise your options are basically you're just setting your icon or your splash screen going on here, or here is Windows. And then you just fill in the values as you want to do it, set it as your current value, and then click build. And it builds for that platform, and you're ready to deploy. So building your final project, super, super simple. Let's exit out of there, so I'm not going to make you watch that happen. Now, before we move on, I guess I'll go ahead and I'll show you quickly one of the 3D projects. Now, it's the exact same process, it's just a little bit more impressive, I suppose, at times. So we'll just close this guy down, and we'll instead make Roboman or Village. Now, we'll go ahead and make Toontown. So, my game, YouTube 9021. I'm basically just making gibberish there. Make sure I haven't used it already. And go ahead and just create a new instance of your project. And this is quite a bit more advanced example, actually. So we'll go ahead and bring up our scene. So here's your Toontown scene, load it up. And now you're seeing the exact same thing, but we are now in 3 dimensions as opposed to 2. So if I hold down Alt and we zoom in, like so, and we can, right mouse button, we can zoom in, zoom out, pan up, pan down, etc. Same keys as before, so the WAS plus Q and E with the right mouse button down. You select your entities in 3D. So as you can see, it's the exact same editing process as 2D, just using 3D assets. And you're going to find that your world itself, so if we go down here, look at the scene graph, each entity here, so this selected guy is, or we'll grab our hero here, is robo_1, which is made up of a node, an animated model, animation controller, a component that controls it, 2 actual components that are controlled attached to it. And then if we come over here, you see same kind of concept, JavaScript controllers. Your main is, once again, very, very simple. A couple more settings based off platform specific, but for the most part, your main is a very simple loading thing that fires up your scene. Here's your Roboman. He is actually I'm not even sure why Roboman's on his own, but Roboman is an imported FBX model. You see here the FBX model was literally just dragged and dropped in, and the right importer will automatically run. And you can configure a few of the settings on that importer. So here you can see it's cut up into animations. So there's animation 0 and animation 1. And the first one is idle, the second one is run. And it's just cut by the duration within the clip itself. So you can also change the so here are the importer settings. We can say, here's how much to scale it by from the original import. But otherwise, that FBX import process is done automatically when you drag your asset in. Your materials, same kind of thing. So here you can see all the various different materials. So let's go down. We should have, I'll just grab, here's a wall material. You can see there's texture channels going to be attached. So your diffuse, your normal, your specular. You have direct access to the Vec3 or Vec4 values of your underlying shaders exposed right here. So with this shader attachment. So materials can define that way. I don't think music does anything. Yeah, there's nothing special for music. Modules is a way of importing in external libraries. So these are 2 JS libraries. So here's a D-pad library that was brought in. So you can import existing JavaScript code trivially by using this module setup. So the models are again just drag and drop in to make them. I don't know if I actually select these if there's any value. Yeah, so you can set up animations if there are any. But that's really kind of it. Like it's a very similar process between working in 2D or 3D, but as you can see, if we go back to the editor here, the experience is very, very different. So let me just pan around, but you can see this example is pretty involved. Go ahead and press play. And ta-da! So, as you see, the detail, the performance is just fine. I've run this on a couple of computers. It's performed just, nothing super advanced here, but it performed as I would have expected it to. Camera orbits around fine. You can see dynamic shadows, the sun moving. And I'll just get out of that in case that sound comes across very, very loud. But the 2D module, 3D module, virtually identical within the editor. The experience is consistent, but you can see the editor is different in each different mode. And this editor itself is obviously one of the big strengths of working with the Atomic Game Engine. And if you ever worked in Urho 3D and used its built-in editor, you will see the differences pretty much night and day between the two. No offense to Urho, by the way. Now, there's also a good chance that you probably don't want to work in the Atomic editor, especially for code. There's nothing wrong with it, but again, there's no built-in debugging yet. Type is very limited in how it works. So you can also work, code completion is very limited in how it works right now. So basically you've just got syntax highlighting inside of the editor, and until that port is done, you're probably going to work external to the editor for your coding experience. And Atomic's actually got you covered there. There's a couple of nice things going on. First off, there is the Atomic CLI, which is a node-based command line interface for working with Atomic. Pretty straightforward. You just npm install atomic-CLI, and that brings the tools in. And then let me just bring up command prompt. Then just using it is a matter of the CLI, and this should bring up the options. Now, the majority of what you're just doing with it right now is creating new projects, adding a platform for them, and running your example. Now, I'll actually show you an example of doing all this stuff. So cd temp. So we'll just go ahead and create a Atomic CLI new my YouTube 922. I'm sure I haven't created that one. So do I have to change to that directory? Yes, I think I do. My YouTube 922. Now we'll go ahead and Atomic CLI add, and then we'll go add Windows platform like so. So atomic.cli run. And boom, there is a brand new project, source created and run completely from the command line. So there's not a ton here that's being done. You can also fire up the editor directly from here, in theory, using edit. But it does allow you to integrate your any kind of editor you wish, and you can fire out to this command line tool to create projects, to run projects, etc. So that's a neat step. And then another part that they've got going on is if you use the Atomic, oops, this is very confusing, the Atom text editor, there's a package available in it that enables you, and let me just see if I can find that. So I'm going to do two things at once here. Another thing I've done here is, actually that's the guy I wanted. Atomic Playground. And this is a set of code. If you go to the text version, I give you the GitHub link to get this guy, but it's a set of example projects and such you could work from, including a TypeScript setup project, which is kind of cool and what I'm going to use in a second. So here's this TypeScript project seed you can use to get started with TypeScript code. But there's also a package available for Atomic Game Engine for run and open. Now, oddly enough, I can't get them to work, so hopefully it's just a temporary problem or something I screwed up. But in theory, you should be able to run them directly from Atomic into here. Now, another neat thing is within this TypeScript example, within Atom, now I do, in fact. So here, let's go up, bring up Atomic. Boom. I do have full code completion here. So you can easily have your code open in, I could open this project up inside of the Atomic editor, but do all my coding here. And you see this is actually in TypeScript that's being generated, but it will spit out this resources directory, which has the resulting JavaScript that we want out. So you can bring it into existing editors such as Atom or VS Code, etc., and get full IntelliSense preview if you do use the TypeScript binding. So that's really nice. That's actually where I would go because I actually prefer using TypeScript over JavaScript. So even if the coding experience in the editor isn't what you want, between the CLI tool, which enables you to build and run completely from the command line, and the existing editors with their language bindings, etc., available, and you have a full set of TypeScript node.d.ts files available for type completion, you can see here. So you can quite easily get the full editing experience even if you don't use the editor, which unfortunately is lacking those features at this particular moment in time. And really, that's kind of it about Atomic Editor or Atomic Game Engine. You've kind of seen it all in this demo. Now, what I haven't gone into is the exact details of its functionality, the breadth of its capabilities, and I will show you that in a second when I look at the help files. But it's, again, built on top of Urho 3D, which is a full 2D and 3D editor. So you're getting kind of inheriting all of that base functionality. So this is a layer built on top of that. So in terms of game engine functionality, it supports most of what you would expect it to support. We've already covered off the platforms, but there's, animation support. There's obviously scripting support, as you've seen many times here. There's, your game life cycle is all being handled for you. There's tiled map loading. There's 2D and 3D physics, there's 3D animation, etc. So most of what you would expect to see in a game engine is in there. Again, it's built over top of the functionality provided by Urho 3D. So I'm not going to go into that with great detail. Now, what I am going to cover, though, is the availability of help and community, and I'm going to cover those both at the same time. Now, one thing that I found very, 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 very confusing with Atomic is, for some reason, the help, or the reference material anyways, is under the video section of the web page. So it's a strange decision, but there is an automatic generated reference documentation available there. So this is pretty much it for documentation, and you can see, as we're scrolling through here, the kind of functionality that's built in there. So you've got light mapping, networking code, particle effects, 3D part effects, the things that you would expect in a game engine, they're all there. And then we bring up a particular class, such as scene. You can see, traditional class references. This is pretty solid, a little skimpy at times, but for the most part, what you need is documented here. And then again, Urho 3D underlying project also has the same basic information. Now, of course, you're going to need to be able to map between the Urho namespaces to the Atomic, and you're also going to have to figure out what they changed and what they broke. So that is not ideal. So in time, hopefully, Atomic, once development is further along, spends a little bit more time on the documentation, because as it stands now, you've pretty much got this reference material, you've got what Urho has made available, plus or minus whatever's actually changed. You got a couple of videos, and then most importantly, and this is going to be a matter of if you're comfortable with this or not, your primary source of information is going to be these examples. Now, you saw all these examples back here in the, let's go on back here. They're available right here, easily loaded and into the editor, and this is going to be your primary learning source. Now, on the bright side, almost everything you're going to want to know is in there. So that's cool. Now, I did run into a few things that I found more complicated than I wanted to. For example, dealing with a sprite sheet. It appears that the only supported format at the moment in time, I could be wrong on this, but is from Spriter. So finding that little piece of information involved me digging across multiple forums, going into the original Urho documentation for sprite-based animation, and then finding out it needed to load this particular file, and it needed to be in a certain file name. It needed to be imp dot, and that was a pain in the ass, to be honest. So that's kind of thing that I would hesitate to recommend this tool to a brand new developer at this state in time, because it does have those missing pieces in the documentation where you're going to have to jump in. But 95% of what you need to know is covered in these examples. The sprite sheet example was pretty much the only case where I didn't find the details. The only other one is that the various callbacks available, for example, start and update, etc. I wanted to find the easy reference to what all of those different game states were, and I couldn't easily find that either. So that's one of those things that in time is going to have to change, and is going to make it a bit of a hindrance for new developers to try and figure this out. But again, early access and documentation normally does come last. So the majority of your learning is going to be from these examples, but thankfully, they're comprehensive and they're good. So the majority of what you're going to need to know is in here. It's just when it's not in there, it can be a little frustrating to try and track down exactly how to do certain things. But again, it is a complete list, so a little bit of both. But I do hope in time, as Atomic matures, so will the documentation, because especially if they want to entice the entry-level or the beginner-level developers, they're going to need that. Now, back to community. Atomic Engine has actually a pretty solid community. Come in here, they've got a forum that's running, and it's pretty active. Now, the nice thing is, and one of those things I really appreciate is, well, here's an example. Oh, there's the first 0. Oh, and it's from the author himself. So yeah, not a single forum question went without a reply of some sort. So that's always nice to see. So not only are people in there and asking questions on the forum, but people are actually answering them as well. Both the creator, who's very, very responsive coincidentally, and the community. So as it grows, that should only improve a bit more and more and more. So from a community perspective, it's pretty good. Now obviously it's early, so it doesn't have anywhere near the size of, say, like a Unity's community or even libgdx, or a couple other larger open source projects, but it's probably comparable or even possibly a little bit bigger than the Godot community. So from a support side of things, actually that might be a little unfair, but somewhere around that area. So it's there, it's growing in time, it will improve, the framework is in place, and the nice thing is the community is proving to be responsive. So if you're willing to wait a little bit, the questions are being asked and they're being answered. So that's good. And then on top of that, they're also using Gitter. Gitter is this weird sort of combination of IRC that lasts forever, and it's searchable. So this is kind of nice. It gives you a very, very, very fast way to ask a question, hopefully get some feedback. So right here I'm showing, so this is actually the author right there, or one of the primary devs anyways, and he was last online at 4:54, whatever time that happens to be. So even if it's an hour or two off. So 2 hours ago there was activity here, and you can see it's pretty constant activity going on. And you can come in here and search for whatever term you're actually having trouble with, a quick jump to the actual answer. So this is sort of, as the chat goes on and on and on, it's going to be kind of more and more documentation on those particular subjects, or it gives you a place to jump in and try and get more direct feedback. So again, it's like a persistent IRC. It's kind of an interesting concept. I wish more people would use this. So that's the nice thing here with this engine. There is good response from the developers themselves. There is an active community that is growing. So both of those are definitely positive points. Another thing that is of some interest here, kind of a double-edged sword, this does illustrate that Atomic Game Engine is very much an early access work in progress, but it also shows you that work is in progress. So we're going to come here and here are the current issues, and this isn't necessarily bugs, but things that are being tracked or changed, etc. And you'll see, 4 days ago, 2 days ago, 2 days ago, 2 days ago, a day ago, 5 days ago, 7 days ago, etc. These are actively being tracked and followed. So development is happening pretty fast, and you can see things. This is like the author opening up, so you've got some transparency on what he's working on. And perhaps what he's going to improve there is the creation of prefabs, which broke on me. But there is certainly a lot of activity going on, and it's not being done in the shadows. You have a good idea of where this engine is going and where it stands at any particular time. And again, to go back to something I said very, very early on, it is based on an established engine. So you don't need to be as worried about the fact that, this is only about a year old. But in some ways, it's 7 or 8 or 9. I actually don't remember how old Urho is, but it's at least 5 or 6 years old, the base it's built on. So this is not an immature engine. This is a somewhat immature set of tools built on top of it. But even then, I experienced in this time absolutely 0 crashes. No, I had 1 crash, I think, but that's it. And you know what, in game development tools, especially Unity, when I play with it, generally I experience a few dozen crashes a day, and that's probably the biggest name in game editors out there right now. So the stability of Atomic is quite solid as it stands right now. You got a set of very responsive developers who are being very transparent about what they're working on. So that's very cool. That's good to see. And as I said, at one point, there is a community that contributed Haxe based bindings. So it's nice to see even the community giving back. As you saw also too, that where did you go? This guy right here, this playground that I grabbed, that's actually not from them. That's from another community member who made a TypeScript-based, amongst other examples, project that you can work from. So the community is kicking in and contributing back. So that's also a very nice thing to see. Now, finally, there is, let's go on back here, a wiki. But it's almost not worth basically mentioning because it is, at this point, just a reference to a couple of things we just saw. So like the documentation we linked at earlier, a couple of videos, and the examples, which is going to link back here. So hopefully this is one of those things that really needs to grow if they're going to start attracting new developers to the scene. But again, in some ways, to be honest, completely new developers probably shouldn't be working with an in-development engine, so or at least an early in-development engine. So that's it. That's Atomic Game Engine. Again, right now it's available for early adoption, which will give you lifetime upgrades. Now you don't have to pay anything right now. You can use it completely free using the community version, as long as you make less than 100 grand and are okay with not having iOS and Android support, or possibly 3D support, depending on how you want to look at that, and are okay with the splash screen. Otherwise, it's something like, again, was $99 for the indie version and $4.99 for the studio version, and those prices are going to go up once this is formally released. Now, another thing there is you do get lifetime upgrades. So this is a single purchase, single time, and then lasts you forever. So that's a cool move as well. No more subscriptions, no more, pricey kind of ambiguous licensing. It's very simple, very straightforward, and well, it's here under early access, it's also quite cheap. Now, at the end of the day, though, you do have to ask yourself, compared to free options, is this the way to go? And that comes down to you. There's a couple of really strong points in Atomic's favor. You've got a very solid editor, a nice component design system, a good set of components available, a mature underlying engine there, and a great set of demos to work on, and I guess most importantly to many people, complete access to the source code. So if that's what you're looking for, that combination, it's a very good choice for you. Now, the rest of it kind of comes down to, do you like the way they did things? Do you like the language choices they used? Do you like working with the tools versus other tools available, etc.? And I can't make those decisions for you, obviously. But you can download the community version, which will give you pretty much access to all of that to try it out and make that decision for yourself. So I can't at the end of the day say if this is a good engine for you or not, but I can say there is a heck of a lot of potential here, and it does have those strengths, and those strengths are pretty strong. You have the ability to have, especially if you're trying to compare it to using something, do I go with Unity or do I go with this? Well, obviously, source code access, the different language options, not being stuck on a version of .NET from the Stone Ages, etc. If those appeal to you, then obviously this is something to check out. Now, make sure, of course, the functionality you need is available in there, but this is a great choice. Now, is it worth money over Urho 3D? Again, that is another one of those things that I can't define what value is to you, but would I pay that difference to have the better tooling if I was going to work with one or the other engine? Yeah, I probably would, to be honest. There's enough polish and value there that I would take that next step. And that's, again, not a slight on Urho 3D, but I do like the direction that Atomic has gone. I do like the editor. I do like the polish and the cleanliness that cleanliness that they're adding on top. So on that level, yeah, I personally would. But again, you can't dictate a value proposition to other people. So really, that is that is Atomic Game Engine. I hope that was of interest to you. Again, there's a text-based version available on GameFromScratch. Be sure to check that out. Now, again, key thing I got to tell you here is this is early access, so expect things to change. Expect there to be some problems or some bugs, etc. It's very much just the nature of the beast, but it is a very mature product for being early access. So hope that was interesting to you. I hope it's an engine that shows some appeal to you. It's definitely worth checking out, and as I said earlier, there's available completely free. You do the desktop version, you can see basically 100% of the functionality. You just won't be able to deploy it to various platforms, but then you can make a decision from there. So that's Atomic Game Engine, available at atomicgameengine.com, or check out GameFromScratch.com for the text-based version of this. Hope you enjoyed that. See you later.